Let's get right into it. Today, we're decoding one of the absolute most powerful, far-reaching forces on our entire planet. I'm talking about the massive global atmospheric shifts we know as El Niño and La Niña. Now, these aren't just some obscure weather terms you hear on the evening news. They are literally the invisible gears that turn the global climate. They dictate who gets rain, who gets scorching heat, and whose crops thrive or completely fail. Just think about this for a second. How exactly does a slight breeze, thousands of miles away, out in the middle of the Pacific Ocean, ultimately decide if a place like India gets hit with devastating droughts or catastrophic floods? It sounds crazy, right? Like the ultimate butterfly effect? But it's actually a massive, perfectly calibrated weather engine. And in this explainer, we're going to break down exactly how those gears turn. So here's our roadmap for today. First, we'll look at the normal Pacific climate. Second, the Walker cell engine. Third, the El Niño disruption. And finally, La Niña and climate change.
All right, Section 1, the normal Pacific climate. Let's just establish our baseline, focusing right on the Pacific Ocean, situated between the Americas on the east and Asia and Australia on the west.
To really grasp what's happening here, we first need to look at a concept called the thermocline. Because the equator gets the most direct, intense sunlight, the surface water of the ocean gets pretty warm. And you'll notice how the warmer, lighter water just sits right on top, kind of trapping the much colder water down below. Well, that specific boundary layer where the temperature suddenly drops off as you go deeper, that's the thermocline. Lock that away in your memory, because this top layer of warm water is basically the high-octane fuel for our whole weather engine. To understand the physics of how this fuel actually moves, let's use a super simple analogy. Imagine you're about to drink a really hot cup of tea. What's the first thing you do? You blow on it, right? When you blow across the surface, you push that hot top layer of liquid away, and that allows the cooler liquid from underneath to rise up. Well, the Pacific Ocean does the exact same thing, just on a massive planetary scale. Normally, you have these strong trade winds, also called easterlies, blowing from east to west. They act just like your breath on that tea, constantly pushing that warm surface water all the way west, toward Asia and Australia. And as that warm water gets shoved away, the freezing cold water from deep down rises up in the east to replace it.
Moving right along to Section 2, the Walker cell engine. This is where it becomes a giant atmospheric machine.
Let's walk through exactly how this engine operates step by step. Step 1. All that warm surface water we just talked about piles up in the west, right against Australia and Asia. This massive warm pool heats the air about it, causing that air to rise. Step 2. As this warm, wet air goes up, it hits the freezing upper limits of the troposphere. It cools rapidly, forming these massive towering rain clouds. Step 3. Since the air is now cool and heavy, it starts to sink back down on both sides of the ocean. And when heavy air sinks, it creates a zone of high pressure at the surface. Finally, Step 4. This high pressure basically acts like a pump, pushing moisture right back toward the low pressure zones. This continuous loop, rising warm air, clouds, sinking cool air, and pressure pushing moisture, is what meteorologists call the Walker cell. Now, this Walker cell doesn't just hang out over the ocean, it directly dictates the survival of billions of people. That cold, sinking air we just mentioned, it builds this massive high-pressure zone over the Arabian Sea and the Bay of Bengal. Meanwhile, further north over Tibet, you have a low-pressure zone. And you know nature hates an imbalance, right? Wind naturally wants to rush from high to low pressure. So that high pressure over the ocean forcibly pumps winds toward Tibet. As they travel, they scoop up unbelievable amounts of moisture from the Arabian Sea and dump it straight onto India. Boom. That right there is what creates the life-giving southwest monsoon.
But here is the multi-trillion-dollar question for us. What happens when the winds get tired? Because nature is never perfect, and these ideal balanced conditions, they can't last forever. The trade winds simply won't always blow with that same perfect strength.
Which brings us to Section 3, the El Niño disruption. This is what happens when the balance breaks.
When those crucial east-west trade winds inevitably weaken, a devastating domino effect kicks off. Because the wind isn't pushing anymore, that giant pool of warm water in the west, it suddenly sloshes backward toward the east, heading straight back to South America. And since the warm water moved, the rain clouds go right along with it, dumping heavy rain on the Andes Mountains. But back in the west, near India and Australia, the air isn't rising anymore. That means our vital high-pressure system completely fails to form. No high pressure means no moisture gets pumped inland, which means the monsoon terribly weakens, bringing extreme heat and drought. It's truly catastrophic on both sides of the Pacific. Even the fishing economies near the Andes get wrecked because the returning warm water blocks all those nutrient-rich cold waters from rising. It's really just a lose-lose situation.
To make it super simple, let's jump back to our teacup. You were blowing hard on the tea, keeping all the hot liquid pushed to the far side of your cup. But the absolute second you run out of breath and stop blowing, the moment those trade winds drop, all that hot liquid instantly rushes backward to where it started. That rapid rush of warm water back across the Pacific, that, my friends, is the absolute essence of El Niño.
And that leads us to Section 4, La Niña and climate change, or as we might call it, the extreme new normal.
So we hear the term La Niña thrown around alongside El Niño constantly. But La Niña is really just the normal conditions we discussed earlier, put into absolute overdrive. If normal conditions are good for the Indian monsoon, La Niña is the steroid version. The trade winds blow abnormally hard, that high pressure over the ocean becomes insanely intense. This just pulls vast, overwhelming amounts of moisture onto the land. So instead of regular fertile rains, you get massive cloud cover, severe downpours, and completely destructive floods. It is literally the exact opposite of an El Niño drought.
And because of all this volatility, a pretty stark reality is setting in. Nature just has no ideal conditions left. Historically, these El Niño and La Niña events happened on a somewhat predictable schedule, usually with a gap of about 5 to 6 years between cycles. But today, because the overall climate is shifting, that historical frequency is completely breaking down. Our baseline is just no longer stable.
Take a look at these temperature anomalies. This is the gap between normal ocean temperatures and El Niño temperatures. Back in the day, a standard El Niño would see water temperatures rise by a gap of maybe 0.5 to 1 degree Celsius. And that small bump was enough to cause all the massive global disruptions we just talked about. But recent data is showing a really dramatic shift.
We're now actually crossing a terrifying 2 degrees Celsius threshold. This isn't just a regular El Niño anymore. Meteorologists are now tracking what's termed a super El Niño. Because this temperature gap is twice as large as it used to be, the resulting heat waves, droughts, and disrupted monsoons become way more extreme and way more frequent. The mechanics of the teacup are exactly the same, but the tea is boiling much, much hotter than before. Which leaves us with this final thought. If the normal baseline we spent so much time exploring today is permanently shifting, and the temperature gaps are doubling to create these super El Niños, what exactly is the new normal for our global weather? As these ancient atmospheric engines are forced to adapt to a rapidly changing planet, how will the billions of us who rely on them adapt in turn? Keep your eyes on the winds.